Good day, guys. How are you? My name is Senator. I'm mathematics and physical science tutor. So today I'm going to assist you with this topic, which is under paper 1, which is Newton's laws and the applications of Newton's laws. Since I'll be revising this topic, but I'm going to start with some basics, the concept of different kinds of forces. Then we will do the definitions. From there, we go to free body diagrams. All those basics, they're very important before you go to answer the questions. So this topic is going to cover grade 11 and grade 12. So I'm kindly asking guys to subscribe to my channel so that I can post more videos on this. Thank you. Let's start. Okay, so since we are going to do this topic, I'm going to use the examination guideline for grade 12. Let me try to open it here. I hope guys you are having this examination guideline. It's very important. So whenever you are reading, make sure that you are reading with your examination guideline, because this examination guideline will guide you on what to start, then on what not to start. And also it's having the guidelines on which topics and which concept are going to be set in your exams. So I hope guys we are making use of this examination guideline. So let's start with the first thing. As see from examination guideline here, we are given different kinds of forces. As you know, we are having different kinds of forces. The first one, there's a weight, then there's normal force, there's frictional force, there's applied force, which can be push or pull. Then there's tension. Then inside the brackets, tension, you get it from a string or cables. So that is it. So we are going to start with the first point. Our first point is saying define normal force. So you guys, you must know how to define a normal force. Yeah, what is a normal force? Let's give it from the definition there. A normal force, which is given as a simple capital letter N. You must know that, guys. Normal force as the force or the component of a force which a surface exerts on an object with which it is in contact and which is perpendicular to the surface. So we are going to start with that first point, guys. I'm going to discuss how do you find out a normal force? How is it exerted from the surface exactly in which it is in contact with? So let's start with that normal force. As we are starting with the different kinds of what? Forces. Different kinds of forces. We are starting with the normal force. I'm not going to write the definition as the definition is given in examination guideline. Here I'm going to demonstrate how do you get your normal force. As you are given from the definition, they say a normal force is exerted. It is exerted from the surface, which means we can only experience a normal force if an object is on the surface. Guys, surface can be a table or it can be your ground. Let's say this one is your table. I'm having this. There's a book here, a box. So what you must know is that in normal force is exerted from the surface, which means it comes from this surface, as you can see here. Then it must be perpendicular to the surface. So this one is an example of a normal force. Normal force exerted from the surface, then that normal force must be perpendicular to the surface. As you can see, this one is my surface here. which is your table. Then check your normal force. Can you see that there's what? It's perpendicular. Okay, let me see different color. It's perpendicular to the surface. So that is the thing that you must know, guys. Whenever a normal force is exerting on the object, you must have a surface. So if there's no surface, for example, I can give an example. If your object is hanging in air, there's no surface there, which means we are not going to experience a normal force. So that is the what that is very important when you are dealing with a normal force. So that is your an example here. So this one it's like it's going to be a force diagram of the normal force, but we are going to talk more about these free body diagrams and the force diagrams. Thank you. So I hope, guys, you did understand what is a normal force. We can move on to the next one. The next point, which is another kind of the force. They're saying you must know how to define a frictional force. Define a frictional force. Let's read the definition as it is given from an examination guideline. They're saying as the force that opposes the motion of an object and which acts parallel to the surface. So that is your definition, guys. The key point here is that frictional force, it must oppose the motion. We know what is a motion, guys. It's the movement of the object. So what you must know whenever you need to find your frictional force, check out what is your direction of the object. What is the direction of the movement of the object? Is it moving to the right, the object, or is it moving to the left? So your frictional force must oppose the direction of the motion. That is the thing which is very important. Let's give an example. Let's say now we go number 2. We're talking about frictional force. Frictional force. And that frictional force, it's small letter f, like this. So we can give an example. And what you must know, usually frictional force, guys, it's exerted on a rough. Your surface must be rough what? Surface. Please don't forget this. It's very important. Whenever your surface is rough, this is where we experience a frictional force. Whenever your surface is smooth, when it is smooth, which means there is no frictional force acting on the object. So let's discuss, guys. Let's say I'm having a box here. It's moving to this direction. Let's say delta x. Delta x is displacement, guys. Don't be confused about this one. This direction of the motion. Okay, let's say it's a directional. I can say motion here, so that you don't get confused. Yeah. So let's say direction of the motion, it's moving to the right. Therefore, your friction, it must move which direction? To the left. Then I'll write small letter f to be your symbol. So that is an example of how you can highlight what? Your frictional force. Can you see the frictional force? That small letter f, it's opposing the motion. It's opposing the direction of the motion. The direction of the motion is to the right, but the frictional force is to the left. So that is it about frictional force, guys. You just need to know this. You just need to understand this. This is how you can demonstrate a frictional force. And as you can see from the definition, they say when it opposes the motion, that frictional force must be parallel to the surface. Can you see this one? It's your surface. As you can see, it's your surface. And can you see that your frictional force, it's also parallel to the surface? That point is very important. So that is it. That is it when I'm talking about frictional force. Thank you. I think we can try. So guys, if you're not understanding, I'm asking you to try. You just try to rewind the video. After rewinding the video, then pay attention. Listen on what I'm trying to demonstrate here, because it's very important. So we are just dealing one by one until we go to our free body diagram and force diagrams. Thank you. So let's move on to the next point on our examination guideline. The next point here, as you can see, after defining frictional force, what you must know, guys, we are having two types of frictional forces. Yeah, That is the thing which is very important. Let's see your next point there. After defining frictional force, we go to define static frictional force. So you must know that we're having two types of frictional force. We're having static frictional force and kinetic frictional force. Let's start with the static frictional force. Yeah, so after defining frictional force, we have two types of what? Two types of frictional forces. Yeah, can you say number one? We have what we call a static. It's a static from word stationary, guys. Static from word stationary, which means this frictional force it's exerted from only stationary objects, the object which are at rest, which are not moving. So I think it will be straightforward, guys. Don't be confused. So it's static frictional force. The number two is kinetic. You know kinetic, guys, from kinetic energy. You know kinetic means what? It's a motion. So which means this frictional force is exerted only to moving objects or objects which are in motion. Sorry about that. Yeah, so these are the two types of forces. I mean, two types of frictional forces. So you must know them, guys. Let's go to the examination, guys, so that you can see their definition. You must know how to define this, guys. If you check your examination guideline, these definitions which are given there, these are the questions which are going to be asked, which are going to be set in your examination. So make sure that you know them, this definition, and you must know how to apply them. Don't cram, guys. Understand the definition. After understand, know how to apply. So I don't encourage you to cram. I encourage you to understand. After understanding, you can able to apply it. So let's go back to examination guideline here. Now they say define static frictional force. Yeah, it's written as Fs. It is small letter f, then that subscript s. So please, you need to know exactly. You must know how to define it. This one, let's read it. It's saying as the force that opposes the tendency of motion of a stationary object relative to the surface. So when you're dealing with the static frictional force, guys, the static frictional force, it opposes the tendency of motion. So which means it avoid an object to move. So which means if it avoid an object to move, it will remain stationary. That is the thing when I talk about static frictional force. I hope, guys, it's making sense. It what you say, it opposes the tendency of motion. So the object will be trying to move. So when the object is trying to move, the static frictional force, it opposes what? That tendency of motion. So that is why it is called static. It makes object to be stationary. It keeps object at rest. That's the thing. I think we're going to do more when I do the formula. There's a formula for this one, so you must know how to apply it. The another type of frictional force, it's kinetic frictional force. The word is explaining itself. Even from that static, I said static means stationary. An object which is at rest. So when you go to kinetic frictional force, kinetic means object which is moving. Now let's read the definition. They say kinetic frictional force, the symbol, guys, it's small letter f and that subscript k. You must know this as the force that opposes the motion of moving object relative to the surface, which means this frictional force, it only acts on the moving object when the object is moving, guys. When the object is in motion. From word kinetic, kinetic is exerted when the object is what? Is moving. It's in motion. So it opposes the direction of the motion. Yeah. That is simple like that. Kinetic frictional force only acts on the moving object. Now there's these terms which are very important. They say no. Know that a frictional force, guys. Yeah, here we are now here. Know that a frictional force, but you must know this one is from the formula, is proportional to the normal force, is independent of the area of the contact, is independent of the velocity of the motion. These points are very important, guys. They are very, 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 very important. So take note, guys. Take note. You must know this. I'm going to explain this using the formula, please. Yeah, they're saying they're saying solve problems using the maximum static frictional force is equal to coefficient of friction times normal force, where F subscript F max is the maximum static. We say this one is the maximum static frictional force, and that which is like a U, it's coefficient, it's mu, is the coefficient of static friction. Yeah, I think let's discuss about this thing. Is very important. So since I discussed, guys, we are still dealing with the two types of frictional forces, which is static frictional force and the kinetic frictional force. So the formula of static frictional force usually to be written like this, guys. It will be maximum. It will be maximum. Why they say why the right is maximum? Because that static frictional force will be maximum, which keep the object to be at rest, which opposes the tendency of motion. So it must be maximum. So that is why it's written as a maximum. So this one is your formula. You must know this. Fortunately, guys, the formulas will be given in your examination guideline. So please don't stress about the formulas. So here it's a mu multiplied by the normal force. So this one is the formula. Where this one is at is the static. Okay, is the coefficient. I mean, it's coefficient. It's coefficient of what? Of static friction. Then you know, guys, N, that capital letter N is what? This one, it's your normal force. Yeah, then I think you know this one. I said this one Fs maximum, and this one it's a maximum static frictional force. This one will become your maximum static. It's maximum. It's maximum static frictional. Also of my space, guys. It's maximum static frictional force. So that is it, guys. We're not dealing with this formula here. So what you know, guys, what you must know, which is very important here, is that you must know that your friction, guys, it depends with your normal force. Let's discuss about it. If you check your examination guideline, they will say if frictional force is directly proportional to the normal force. What does it mean, that point? Check your formula, guys. It's on the formula. What you must know is that when you increase normal force, guys, your friction here will also increase. That is the that is very important. Let's say if we keep our coefficient of static friction constant, if we increase normal force, your friction must also increase. That is the thing. So that is the meaning of what? Of whereby they say your frictional force is proportional to the normal force. So it's in other way, when normal force decreases, your frictional force will also what? Decrease. So that thing is very important. You put it in your mind, guys. Then I also said friction will also depend with the surface, the roughness of the surface. Is your surface rough or is your surface smooth? This one is another factor which affect what? Your frictional force. So don't forget those things, guys. It's very important. Then other points, you must know that the frictional force does not depend with the area of the contact. So it does not matter. It does not depend with the area of the contact. If you check your formula, we don't have area there. So which means frictional force does not depend with the area of the contact. Then other thing, frictional force does not depend with the velocity of the object. Why? Because from the formula, we don't have velocity. So which means velocity does not affect our frictional force. So these are the things that you must know, guys, which are very important, which can help us to deal with this kind of problems. So they can ask you in exams. They can ask you in exam, guys, these kind of questions. How frictional force is affected by what? By the normal force. But as time goes on, we're going to do more of this. There's no need to worry about it. So this one, what you must know, which is very important, guys, here, know this formula. So we must not apply it. But we are going to do the calculations as time goes on. So let's move to the next one. The next one, we'll talk about what? The kinetic frictional force. The kinetic frictional force is represented by what? It's Fk is equal to, which means your coefficient of friction here is going to be coefficient of kinetic friction, which is mu times normal force. Whereby this one is what? It's kinetic frictional force. This one Fk, it's kinetic frictional force. Then that mu, we say it's its coefficient of kinetic friction. Yeah, good. Then this one we talk about, it is N is normal force. So guys, which is very important, you must know that all forces, I hope you know guys, the SI unit of force, all forces are measured in what? In newtons. So these are newtons, guys, here. Don't be confused about that. So that one is the formula. Unfortunately, guys, luckily, guys, the formula will be given in your examination. I mean, if you check your list of formulas, yeah, the formula is given. So if you check this formula here, it also support that if you increase normal force here, if you increase normal force, your Fk will also what? Increase. Is the same explanation. So which means if normal force increases, your Fk will also what? Increase. So in other way, you can say Fk is directly proportional to what? The normal force. So that's the thing which is very important, guys. So you must not apply this formula when you are doing the calculations, but you are going to do it as what? As time goes on. So don't worry about it, guys. Since now we are doing the basics, we are doing the definitions, I'm explaining you all these things. Yeah. Okay, let's see here. Okay, the next part here, they're talking about it now. They say not here. Not if a force F, you know that force F, it's force applied. Applied to an object parallel to the surface does not cause the object to move. F is equal in magnitude to the static frictional force. Yeah, okay, here they're talking about static frictional force. I'm going to explain this statement here. Then they say the static frictional force is a maximum just before the object starts to move across the surface. If the applied force exceeds the maximum static frictional force, a resultant net force accelerates the object. Yeah, so here what they're trying to say, guys, here, let's go back to this scenario. Now they're saying, you know, the other type of force is force applied. Let's say this object here, it's experiencing a force applied like this one. Let's say, let me write in let's say it's 5 newtons, so that, guys, it will be straightforward to you. Yeah, so what is, let's say your surface is rough, it's a rough surface. Yeah, so it's like this force applied, it's acting to the right, so it's like it's pulling the box to the right. So there is going to be your friction here, which is going to keep this object to be at rest. It's going to keep this object to be stationary. So that kind of force, we call its maximum static frictional force. So it must be also be equal to, for example, guys, it can be 5 newtons or more. Like, I'm giving an example, or more. So which means if your maximum static friction force is equal to 5 newtons, it's going to be equal to the force applied, which means it will remain at rest. Are you getting the sense? So this is what the statement is trying to say. But unless this 5 newton, unless if you are going to increase your force applied, when you increase your force applied, which means maybe it's going to be more than what? 5 newtons. So when you increase your force applied, this is whereby your box will start to move forward. The box will start to move to the right. Therefore, when the object starts to move, guys, what you must know is that we are no longer going to experience what? Maximum static friction force. This is where we are going to experience kinetic frictional force. So that's the thing. As long the object is stationary, there is maximum static frictional force, like this scenario which is given there. So that is it about this thing, guys. There's no need to stress about this. It's very important to understand this. So that is it. But as time goes on, we are going to talk about this thing. We're going to talk about Newton's laws. We're going to talk about the resultant net force when the object is accelerating. But don't worry about this, guys, since now we are dealing with the basics. So our next part here from examination guideline, let's do what? Let's do force diagrams. Yeah, let's do, there's force diagrams, free body diagrams. So according to your syllabus, you must know how to draw a force diagram. You must know how to draw a free body diagrams. Yeah, then you resolve all those things. We are going to resolve these things, guys. Don't worry, there's no panic, as we are having a lot of time to do these things. But as you can see here, guys, we did normal force from here. Different kinds of forces, weight. Yeah, I think I was now missing this one. Yeah, weight, guys. Since I think in your exam they will not ask you the definition for weight, but you must know how to draw you must know what is going to be direction of the weight. When I talk about weight, usually weight, it is whereby all objects, guys, all bodies with a mass, they are attracted to the ground with the force of gravity. Yeah, all objects, guys, they are attracted to the ground with the force of gravity. So what you must know, that weight usually is attraction force due to the force of gravity. So what you must know is that weight usually it's always act downwards like this. You must know this one, it's a weight. Some they say weight, it's capital letter W, or some they can say force of gravity like this. I think it's another way. Okay, they can say FG, it's another way. So you must know, guys, weight is exerted downwards to the ground. So your force must directly down to the ground or to the earth. So what you must know, guys, weight is exerted to all objects, whether it's on the surface, like you see here, it's like this object is in the air, it's moving in the air, there's weight. Even if your object is on the table, on the surface, we still experience what? Our weight like this. So that's the thing which is very important when we're dealing with the weight. Weight is exerted whether there's no surface or there's surface. Weight is always acting on that object. So that is the force that you must know, guys. That force is exerted anyway, whether there's no surface, whether there's a surface. Weight is always acting on the object and moving downward to the ground. So that is it, guys. So I hope, guys, you understand this, but you are going to do more of this by going to the applications, like all the formulas, all the scenarios. Then there's force applied, guys. Force applied, it depends with the direction which is given. Force applied, okay, force applied, yeah, it depends whether it's a pull or it's what. It's usually it's a pull or a push. So I think, guys, you understand this one. When it's a push, maybe there's someone who's pushing a box here like this. Let's say this guy is pushing, yeah, a box. So maybe if you are pushing, which means your force applied, maybe to be like this, yeah. Yeah, you see, we can say this one, it's a capital letter F, guys. You must know that it's pushing what? A box on the surface. Yeah, since my space too small here, so this one is a push. Yeah, then pulling, when it's a pulling, which means there's someone who's what is pulling. Yeah, let's say this guy here is moving, it's going that side, it's pulling with the string. Maybe not with the string, let's say it's just pulling it forward, for example. So which means here it can be like this here, if you draw it clear. Yeah, then force applied. Yeah, so it's pulling it forward, pulling to the right. So that is the thing that we must know about force applied. But we are going to do this. But what is very important, the symbol for force applied is capital letter F. Then the symbol for friction is small letter f. So that thing you must know is very important. Yeah, okay. Let's go to body diagrams now, guys. Yeah, force diagrams, free body diagrams. Here they say, according to a syllabus, draw force diagrams. You must not draw a force diagram. Then they say draw free body diagrams. So I'll give you an example, guys. Since now here we are doing basics, so we are going to start with an object, which is let's say scenario 1 here. We're going to say this one is an object. Let's say it's 5 kg. Yeah, let's say there's a force applied of 60 newtons. It's applied to the right. Let's say our surface is smooth or what, or a friction. Yeah, what did I say, guys, about this thing? I said if your surface is smooth or frictionless, which means there is no friction acting on the surface. In another way, guys, what I'm trying to say here is that your frictional force acting on the object is what? It's zero. I think it's clear like that. The frictional force acting on the object is what? Is equal to zero. So what you must know is that here, if you want to draw a force diagram for this scenario here, the force diagram, guys, you just draw a box. Your object is going to be a box. I think I want to give you a difference between, since here my space, okay, let me try to rotate like this here so that I'm going to have more space here. Yeah, so like, okay, sorry about that, guys. Let me just try to rewrite this scenario. I'm having what? Yeah, I'm having a 5 kg. Yeah, then there's a 60 newtons. So I can say, yeah, it's smooth, guys. It's rough. Yeah, it's smooth. Or what? Friction. Frictionless surface. Yeah, so if it's like this here, yeah, I'm going to give it in so that you can see, guys, different between these two. We're having what to call a what? From your examination guide, they say you must know how to draw a force diagram. Let's say I'm going to draw my force diagram here. A force diagram. Then there's what? A free body diagram. Yeah, let me use different color here. Yeah, thank you. So a force diagram, guys, you just draw your object is going to be, you just draw that as a box, your object. So here, as you see, that 5 kg box, you represent it as what? As a box like this here. But for free body diagram, guys, your object, you represent it as what? As a dot. So this thing is very important, guys. They can ask in exam. So in exam, they can just say draw a force diagram or draw a free body diagram. But in most of the cases, from my experience, they always ask for free body diagram. So you just need to know how to draw those things, guys, please. So here for force diagram, you see we are drawing our object as a block. It's like this, as a block. It's like a square or a rectangle. Yeah. Then you highlight which forces are acting on the object. Let's go to our original diagram. On our original diagram, let's try to label the forces which are acting there. You remember there's a force applied here, which is 60 newtons. Then there's no friction here, guys. If there's no friction on the surface, which means I'm not having what? My small letter f. I'm not having friction. So I don't want to see friction, guys, on this scenario. So which other force is acting here? We agree that all objects, they experience a force of gravity. All objects, they have a weight. So which means I'm going to have weight here. You see? Guess what I'm doing? I'm drawing it on the original diagram. Then there's what? Another force is what? It's a normal force, which must be perpendicular to the surface, which is exerted from what? From the surface. So let's go to our diagram here. We can just say here I'm having weight it acts from the center of the mass, but it's fine since we are talking about what? Please, I think here, let me just try to, it must be perfect, guys. Yeah. Yes. Sorry about that, guys. Make sure, guys, when you're drawing your free body diagram here, I mean your arrow must touch this line, please. So this one is our weight, yeah, calculator W. Then I'm having what? I'm having normal force, which is acting from the surface like this. Then I'm also having what here? Can you say here? I'm having what? Force applied. Guys, this one is going to be a force diagram. I hope, guys, it's straightforward. I don't think, guys, you are confused about this thing. I hope you can see it's just a slight difference. But for free body diagram, guys, you represent your object as a dot. It's a must here. So here I'm going to have what? My weight. Then I'm having my normal force. Then here I'm having my force applied. Yeah, make sure, guys, when you're drawing your forces, guys, your free body diagram, make sure that this line here must touch the arrow. If you leave a space like this, guys, like this, if you do like this, you don't get a mark. That one is very important. Most of the learners, they make mistake about this thing. So please make sure that your line must touch what? Like this. It must touch your arrow, please. And it must be perfectly touching. I hope, guys, don't make this. And there are some students who write a free body diagram like this. So make sure that if you do like this, guys, you must shade your arrow, guys. Yeah, inside. Make sure that it's shaded. If you don't shade inside there, you lose a mark also. They'll be strict about that, guys. So this thing is very important that I'm telling you, guys. You must know how to do this. So that is it about free body diagram and our force diagrams. So the forces which are acting on this object is only 3 forces, guys, since we don't have frictional force acting on the surface. So I hope, guys, it's clear. So this one is our scenario. It's our example 1 here, how to draw free body diagram if there's no what frictional force. Let's go to the second scenario. I'm going to use the same diagram, guys, but the difference, what is going to happen here? Let's say there's what, I can give an example here. Let me just do a black color. Let's say now here is now a rough surface. Yeah, you know what does it mean, guys? You'll be told in exam, if your surface is rough, you'll be told, or if the surface is what? It's smooth. So if there's a rough surface, let's say it's still using 5 what? 5 kg. H my kg here. Let me use it must be small letter, please. Yeah, like this. Yeah. So here, let's say I'm still having what? Your force applied of 60 newtons. Yeah. So remember, guys, before we draw our force diagram and free body diagram, let's try to list the forces which are acting on the object from the original diagram. So this is what you must do in exam, guys. Whenever you're doing a force diagram and a free body diagram, try to label the forces acting on the object from your question, from the original diagram on your question. If you do that, guys, you don't make a mistake. So let's do it. Let's label it from my original diagram. You know that this one is what? That's 60 there. This one will become what? This one will become your force applied. Then which other force is acting here? I said yes, it's always weight is acting on the surface here, like this. Then there's what? A normal force always acting perpendicular to the surface. Now, what is the other thing? Let's assume, guys, that the object is moving to the right. Okay, object moving to the, what you must know, guys, which is very important, don't focus with that force applied. Focus with your motion. What is the direction of the motion, please? Yeah, direction of the motion is very important. You must know it. Don't focus with that force applied, because most of the learners, they make a mistake here. They think that it's always friction. They think that it's always friction opposes what? Force applied. Sometimes not like that, guys. Because from the definition, we said friction opposes the motion, not friction opposes force applied. Please don't make that mistake. because sometimes force applied can be in the same direction with your friction. So please, you must know, you must take note this, please. Friction opposes the motion, not friction opposes force applied. I hope it clear there. So before we draw our force, the direction of the friction, you must understand what is the direction of the motion. What is the motion? Is it moved to the right or it's moved to the left? Don't focus with what? With the force applied. I'm repeating again. Please, because I tell that most of the students, they make mistake there. And it too affect you. So now, what is the direction of the motion? I said our object is it's moving to the right. I just add another point which is very important here. Yeah. So which means if direction of the motion is moved to the right, therefore our friction, what is going to be the direction of the friction, since it's rough surface, guys, and they say it's moving. So if it's moving, it's going to be kinetic frictional force. But to be safe, guys, let's just use a small letter f, please, just to be safe. Small letter f, though we know that it's fk. So which means here I'm going to have what? Our small letter f, which is a friction. It must oppose direction, because my direction of the motion is to the right. Therefore, friction must be to the left. So that is the thing. So let's go to draw our what? Separately. We are going to draw here our force diagram. We are going to have our force diagram. Then free body diagram. Yeah, that is it here. So let's do it, guys. It's very easy, nothing to worry about. This thing is very easy. So I said for force diagram, you just your object, you represent an object as a what? As a block, like this. So let's label the forces acting here. I already said there's what here, there's weight, there's also normal force here, there's what? Force applied, and here there is, it's a small letter f here, friction. Just seem like that, guys. That is your force diagram. Then free body diagram, which means the object for free body diagram represented as what? As a dot, like this one. Yeah, please, your dot must be, please, must be a dot. Please make sure that you shade it very well. So here I'm saying we're having what? Weight, there's normal force. Since you say normal force must be perpendicular to the what? To the surface. Here it's force applied, and here it's what? Yeah, but I think maybe this one can make it small, but it's fine. I don't think they'll be strict about this thing. Yeah. So that is why I'm making these frictions to be smaller, because since the object is moving forward, so which means force applied must be more than your frictional force, which is going to be what? Yeah, fk. But then usually, guys, they encourage you to just use small letter f to avoid those mistakes. Some of the learners, they make mistake. So whenever it's friction, guys, either it's it's kinetic frictional force or a static frictional force, use a small letter f to be safe. So this is your, yeah, this is your free body diagram on the right hand side and the force diagram on the left hand side. So guys, I'm asking you guys, if you're not understanding, try to rewind the video, try to repeat again what I was trying to say, so that it will stick in your mind. What I'm talking about here, guys, I'm doing the basics, I'm doing step by step, so that when you do the calculations, you're going to be fine. So that is it. So that is thing which is very important when you're dealing with what? With the free body diagram and our force diagram. So this one was our scenario number 2. So we can go to scenario number 3. For scenario number 3, I'm going to draw the diagram here. It will be like this here. Let's say you're given okay, scenario number 3 here. There is a 5 kg here block, and there's a force applied which is acting at an angle, guys, please. Yeah, let's see. it's 20 degrees. Yeah, let's see it's still a rough surface. Then let's assume that the box is moving to the right. Yeah, please, I'm emphasizing this thing. It's very important. You must know the direction of the motion. So that is it. So here for this scenario, guys, we are going to draw what? We're going to draw our force diagram. Let's do it. We draw our force diagram. And free body diagram. So that is it here. So let's do it. Before we draw it, I said, guys, what I'm encouraging you guys, try to label your forces from your original diagram. Then you go to answer the question. So you'll be having your question paper, guys. On your question paper, go to your original diagram on the question paper. Then list the forces acting on that object. Then after you list them, then you go to answer the question, so that you don't make a mistake. I think it's making sense. I hope I'm making sense, guys. So let's go to our original diagram. You see here, this one here, it's force applied. It's acting at an angle of 20 degrees. It's no longer parallel to the surface. Then which other forces are acting here? You know that is obvious. We are going to have what? Our weight, then which is always acting down to the ground. The normal force acting from the surface, which is always acting perpendicular to the surface. Yeah, then we are having, since the object is moving to the right, so the friction must oppose the direction, which means the friction must be to this direction, small letter f. You know the type of force, the type of frictional force here is going to be kinetic frictional force, since the object is moving. But yeah, I'm just writing small letter f, guys, to be safe, guys. As I said, if it's what, if there is a friction, guys, just write a small letter f to be safe. That is the thing. So now you are going to transfer this to our what? To our questions. So we just copy as it is. Just copy it, because if you try to label your forces from your original diagram, you'll be avoiding those mistakes. You'll be avoiding those silly mistakes. So we just copy as it is from what? From that question, from the diagram. Then let's go to our force diagram. We said force diagram, we must represent our object as what? As a block like this. So here, as you can see, we're having normal, I mean weight always acting down from the center of the mass. Then we're having what? Normal force like this from the surface. Then I'm having my force applied. Then I'm having my friction. Remember, guys, we said friction must be what? Must oppose the motion and parallel to the surface. I hope guys just remember this. So that is your friction here. Now let's go to our what do you call this one? Our free body diagram will represent our object as in a dot like this. Please, guys, please don't forget this. Then there's what? Weight. There's normal force. Here there's, you just draw as it is, guys, from the diagram. Force applied. Here there's what? Friction, which is parallel to the surface. So that is the thing. Now this one is a force diagram and a free body diagram for this scenario. I hope, guys, you're understanding this. Make sure that you understand. These are marks that you must get in exam, which are 3 marks. Don't lose marks for this one. Don't lose marks for the definitions. Don't lose marks to draw a free body diagram or a force diagram. Usually it can be 4 marks or 3 marks. So make sure that you understand this, guys. It's very, very important. Yeah, so I think we'll go to another scenario. Another scenario here, it will be like this here. Yeah, let's say you're given a 5 kg block. Okay, now there's a force applied acting like this. Yeah, guys, here these things are very important. What I'm telling you here, you see here, it says 60 newtons. It's still to the 20 degrees, but it's acting in that direction. Can you see, guys? Then your surface is rough. It's a rough surface. Let's assume that the box is moving. It's moving to the right. Guys, here we're still going to draw what? Our force diagram. And what? And the free body diagram. We're still going to answer the same questions here. Force diagram. So as I said, guys, we just before we answer our questions, let's first go to our original diagram. Let's draw the forces which are acting there. Yeah, as you can see, this one is going to be your 60 newtons. What? This one is a force applied. It's obvious. Then since it's a rough surface, but the obvious, you know that all object, guys, there is a weight. So I'm moving my weight here as usual. Then my normal force as usual is always perpendicular to the surface, normal force here. Then frictional force direction, since the object is moving to the right, so friction opposes the motion. Then remember, guys, you see the way your friction is acting. It's acting like that. Yeah, I think, can you see the way your friction is acting here? It's acting like this. I think you can see, guys. So what you can do, you can just extend here. If you extend here, let's say if I'm going to extend, let me try to show you guys. You usually don't live like that here. You can extend, which means it will be like this in this direction. I hope you are getting the sense, guys. So which means you can say force applied, it's acting like this direction here. Yeah, let's wrap here, which means here I can wrap. I hope guys you did understand what I'm trying to say here. This one is very important. Yeah. Then next we're having what? Our weight and normal force. Then there's what? Friction. Then lastly, let's go to our free body diagram. Here, free body diagram. Obviously, I'm going to have what? Weight, normal force, friction. Then here, please, guys, can you see the way I'm drawing my force applied? This scenario is very important, guys. Some of the learners, they are confused to how to do this type of, yeah, whenever your force applied is acting like that at that angle. So please, guys, make sure that you know this. Because here I'm just bringing you all these scenarios so that you don't miss up. You don't miss how to draw a free body diagram. I hope, guys, it's clear from this one. If you are not understanding, try to rewind the video, then listen again, careful, so that you understand this. It's very, very important, guys. There's no way you must lose marks, guys, to draw a free body diagram. Free body diagram, these are free marks. So make sure that you get all these marks to draw what? A free body diagram. Thank you, guys. So let's go to the next scenario. Our next scenario, it will be like this here. Let's say, okay, now we are talking about the inclined plane. Yeah, in the examination guideline, you must know to draw a free body diagram on the inclined plane, say 5 kg. So let's say your force applied is parallel to the surface, which is what? Let's say 60 newtons here. Yeah. Yeah, this is your, so let's say this is a rough surface. Then a box moving. Let's say the box is moving. It's moving upwards, which means your box, the direction of the motion is the same direction with your force applied. Yeah, that is it. Yeah, I'm specific about this, guys, because you must know that since it's a rough surface, when you are considering our friction, we need to consider what? We need to consider the direction of the motion. So yeah, let's do the same thing. We're still drawing what? Our force diagram. Here it's a force diagram. Here it's a free body. It's a free body diagram. Okay, let's move on. Let me play color. Yeah, before we answer our question, let's list the forces which are acting on the object before we answer our questions. So let's see here. Already this one is a force what? It's force applied. Yeah, then it's a rough surface, guys. It's moving to the motion. What is the motion, guys? We say motion is moving to the upward, but let's try to draw the force which is obvious, which is acting on the object, which is always acting on all object. We say it's force of gravity. It's what? It's gravitational force, or it's a weight. But since this one is a ground, so which force is that? That force is what? It's a weight. Yeah, remember, guys, here you can see your weight is acting downwards to the ground, downwards to the earth. And then what is the direction of the normal force? Normal force must be perpendicular, guys, please. Now can you see this scenario? Your normal force and the weight, they are not in the same plane. Yeah, I think some of the teachers, they write like that, but it's fine. Let me just do the same thing so that I don't confuse you guys. They can just draw like this here. It's still fine. Yeah, so that I'll try to show that here. If you check here, if you check your normal force and weight, they are not in the same plane. So that's the thing that is a variable that you must know. Then other force here, frictional force, it must oppose what? The direction of the motion. So these are your forces acting on the object. So when you're drawing, okay, obviously here, our force diagram, guys, our force diagram. So it must be inclined. And I'm just trying to draw like so that, guys, you don't make a mistake. Those dot lines. I'm having what? My weight always acting to the ground to the okay. I mean my weight here down to the ground. Then I'm having some. I can just start. It's fine, guys. If you like this here, then there's force applied acting to the parallel to the surface. Then there's what? Friction. I hope, guys. So make sure that when you're done drawing, guys, you must rub those lines, guys. See? These ones here, please take them out. Don't leave them. You must take them out, these lines. I hope you are paying attention. Yeah, so now this is your diagram. Those, I was trying to use them so that you don't make a mistake. So you must write them after you are done. Thank you for that. So yeah, it's okay. Let's go to our free body diagram. We represent our object as a dot. So I'm going to have, yeah, you know that over here I'm having force applied. Okay. Then I'm having friction. Then I'm having normal force perpendicular to the surface. Then here I'm having what I call this one. It's going to be your weight. Yeah, can you see normal force? What I was trying to say, guys, normal force and weight, they are not in the same plane because it's acting on the inclined plane. So you must know this. Yeah, but you must leave a diagram like this, guys. Don't add those other lines, because you can lose marks for that. So that is it. This one is a force diagram. This one is a free body diagram. Yeah, thank you, guys. So I think we can move on next scenario. Next scenario, it is whereby we're going to have maybe you'll be given what? Let's do like this here. You'll be given two boxes which are connected with the what? With a string. Like this. Let's say this one is 2 kg. Sorry about that. Okay, let me just increase my size of the. So let's say it's 2 kg, and here it's what? It's 5 kg. Yeah, let's say here I'm having what? Yeah, I'm still using that same for 60 newtons. Yeah, let's say it's rough surface. Then boxes, or you can say blocks. Some they use blocks. Let's say blocks. Okay, let me use the other terms that they can use in exam. Blocks, moving right to the right. Yeah, so you must know, guys, what you must know is like these are two boxes, they are connected with a string or it's a cable. So what you must know, which is very important, the type of force that you experience on the cable or on the string, we call it is what is tension. So you must know it's T, it's capital letter T. So we need to draw a free body diagram for both boxes, which is 2 kg. Maybe let's start with your 2 kg here. For 2 kg, we need to draw what? Our force diagram. Then draw a free body diagram. Yeah. So let's see here. Yeah, which forces are acting on this 2 kg box? For tension, the tension which is acting for 2 kg, you must know that the tension which is acting in that way. I think this one is going to be my last example, since you are going to apply Newton's laws. Newton's laws, we are going to do it on our next lesson. So I hope, guys, you are going to subscribe. Make sure that you subscribe to my channel so that you don't miss out. I'm doing revision here for grade 12 for those who are going to write junior exams and for those who are going to write for final exams. So make sure that you subscribe to my channel so that you don't miss out with the more videos that I'm going to post. So here, tension for 2 kg is moving to the right, but for 5 kg, it's moving to the left from Newton's third law. Same magnitude but different direction, but we're going to do this when I talk about Newton's laws. That is thing. Okay, so which other force obvious we are always acting? Our weight acting downward. Then there's what? Normal force perpendicular to the surface. And then there's also what? Since there's a friction, small letter F. So which means my force diagram here is going to be like this here. Weight, normal force, then T, capital is tension from that cable. Then there's what? Frictional force. Then for free body diagram, yeah, I'm going to have what? My capital letter T. Yeah, as we are just copying as it is from the original diagram. Weight, normal force, and what? So that is it, guys. Your force diagram and free body diagram for this 2 kg. So I hope, guys, you must know how to draw even for what? For 5 kg. Yeah. For 5 kg, make sure that you know that here there's force applied here. Here there's what? My weight. There's normal force. So you just do the same thing as I did here. So guys, I think this one is our last example. I'm going to upload more videos on this topic and also for other topics for paper 1. So kindly follow my channel so that you don't miss up. Thank you. I hope you are going to enjoy my lesson, guys. As I said, I'm Senator. Thank you, guys.